Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. In this video we're going to be drawing linear inequalities. So we're going to be representing linear inequalities as graph regions. To start with, we need to be super good at drawing our straight lines. So here are 4 straight lines I would like you to draw on the axes given. Please pause the video and have a go. Well, I really need you super good at this particular skill. This vertical line here is the line x is -4. This line here is the y-axis, yes, but we can give it an equation x equals 0 line. This here is y is equal to 2, and this one here is y is equal to 0. That's another name for the x-axis. Now I need you really good at drawing those and knowing when one's vertical and when one's horizontal, etc. So go back to your building blocks if when looking at these answers you don't have a clue why they're like that. And we're going to use this skill for representing inequalities as a region of a graph. So let's go straight in and have a go at the first one. Shade the region of that graph satisfied by the inequality x is strictly less than 4. Now when we're doing this, we're going to draw ourselves the line x equals 4, okay, and we're going to use that to shade the region we're interested in. Now because it's actually strictly less than 4, we're not going to draw a full straight line. We're going to use a dotted line, and we're going to draw this here like this, and we're going to draw the line x equals 4 with a dotted line. Now it's dotted because x being 4 is not allowed as a solution. If it was x less than or equal to 4, we would have drawn a full complete line. Now the question asks us to shade the region satisfied by the inequality. So all the x's that are less than 4 are to the left of this line. So it's all of this region here that we should shade, and we can test any point in particular. Let's just test that point there. At that point there we have x is 1 and y is 2. X being 1 is certainly less than 4. So therefore this is the region we're interested in. So we're going to shade it like that. Okay, let's have a go at another one. Shade the region satisfied by the inequality y bigger than or equal to 4. Pause the video, have a go. Well, we're going to draw the line y is equal to 4, and this time we're going to have a full line. We're not going to have a dotted line because we have a bigger than or equal to sign. So y equaling 4 is a allowed place. Now we're looking for all the y values bigger than 4. So we're going to actually shade above the line here to identify our region. And just pick any point there, just double check you've got the right region. That point there is the point 1, 5. The y number is 5, and 5 is certainly bigger than 4. So all the points in this region are the points such that y is bigger than or equal to 4. And we're done. Let's try another one. Pause the video and have a go at this one. So we're told to shade the region satisfied by the inequality x is less than 4 but bigger than or equal to -1. We're going to draw ourselves 2 lines here. The first line we're going to draw is the line x equals -1, and because it's a x is bigger than or equal to -1, we're going to use a full line here. So the line x equals -1 is that line there. Okay? Then we're going to draw the line x equal 4, but we're going to have it as a dotted line because x has to be strictly less than 4. So I'm going to draw a line there at x is equal to 4, but I'm going to make sure that when I draw it, it's actually a dotted line. Like that. Now we're looking for all the x values, x less than 4 and bigger than or equal to 1. So what are we going to shade? Well, we should shade in between these two like that. And that would be the region that we are talking about in this case here. And pick any point in here just to double check that's true. Say that point there. That is the coordinates x is 1 and y is 2. And is it true? We're interested next. The x value is 1. Is it true that 1 is less than 4? Absolutely. Is it true that 1 is bigger than or equal to -1? Absolutely it is. And therefore we have shaded the right region. It's always a good idea to test the point of what you shade just to make sure it's correct. Let's have a go at another one. Pause the video, have a go at this. Well, what two lines are we going to draw? We're going to draw the line y equals -3, and we're going to draw the line y equals 0, which is that line there. The y equals 0 line is going to be a straight complete line, but this line here should be a dotted line because it's a strict inequality, and you must make sure you do dotted lines for those, like that. So what are we going to shade? We're shading the y values between the two lines, so we're obviously going to shade this region in here. Again, as we always do, just pick a point in there and double check that the y value you found satisfies that. This is the coordinates 1, -2, and the y value there at this point is therefore -2. Is it true that -2 is less than or equal to 0? Absolutely. Is it true that -2 is bigger than -3? Absolutely. So testing that point worked out really well for us, and we've got the right region. Another one here, let's shade the region satisfied by all of these. Okay, there's a lot to draw here. This one here, I'm going to draw the lines x equals 0 and x equals 3, but this one being dotted, this one being complete. So drawing the line x equals 0 is that line there, x equals 3 is that line there, but I'm not allowed for it to be a complete line, it must be a dotted line. Okay, let's then draw the line y equals -1 and y equals 2, y equals -1 being dotted and y equals 2 not being dotted. So let's do that. That's the line y equals 2, and that's the line y equals -1, but that one's got to be dotted. Okay, and now the region's satisfied by all of these. Now we just have to have a quick think about it. It's x between 0 and 3, so between these two lines, and y between these two lines. It looks to me like it's this square in here. And let's pick a point in that square and check it satisfies both inequalities. That is the coordinate x is 2, y is 1. Is it true that 2 is less than 3? Yes. And bigger than or equal to 0? Yeah. Let's make sure 1 satisfies. Is it true 1 is less than or equal to 2? Absolutely. Is it true that 1 is bigger than -1? Absolutely. So that point there satisfies both inequalities. We can feel comfortable with the region we've shaded. And that's it for this particular video. Thanks for watching.